Dear students, now today we are going to discuss about the second theorem under the GEODESIC. So let us look the first part of second theorem under the GEODESIC. What is the statement? Statement is कि when v is equal to c for all values of u, a necessary and sufficient condition that the curve v is equal to c is a GEODESIC is e2 plus f e1 minus twice EF1 is equal to 0. The symbols has their usual meaning, which is discussed in the previous chapter of this differential geometry. On the curve v is equal to c, u itself may be taken as a parameter so that the equations of the curve are u is equal to t and v is equal to constant. We know that a curve on a surface is geodesic if and only if capital U del t over del v dot minus capital V del t over del u dot is 0. This is equation number 1, and from where this equation came, this is the statement of the theorem 1 in geodesic. So to obtain the condition for the parametric curve v is equal to constant to be a geodesic, we find u, v, del t over del u dash, del u dot and del t over del v dot and use them in equation 1. Okay. So here now only the question is how to find u, v, del t over del u dot and del t over del v dot. So we will look in the next PPT. From the definition, we know that this equation t is equal to half e u dot square plus twice f u dot v dot plus g v dot square, where e, f and g are function of u and v. I believe this equation remembered by all the students, so there will be no problem. Just you write this equation and go for partial derivative del t over del u with the symbols. We know that the symbols in case of v, we use u2 E2, F2 and G2. Del T over del U, we use E1. So half of E1 U dot square plus twice F1 U dot V dot plus G1 V dot square del T over del V is this. Half of E2 U dot square plus twice F2 U dot V dot plus G2 V dot square. And del T over del U dot means EU dot plus FV dot. And del T over del V dot is EU dot and plus g v dot, because 2 times this will be cancelled out. Okay. So now according to choice of the parameter, u dot is 1 and v dot is 0. Now putting these this value in the above equation, again we can rewrite the above partial derivative as del t over del u is half of e1, del t over del v is half of e2, del t over del u dot is e, and del t over del v dot is f. Here is only one time of equality. Okay. So this is equation number 3. Now using 3, we get u is equal to this equation. Just you use this 3, then the value of u, after putting the value, we may be able to write u is equal to d by dt minus half e1. Now using the formula for the derivative of e as a function of u v, we obtain u is equal to, and after this simplification, we will get e1 u dot plus e2 v dot minus half of e1. Since u dot is 1 and v dot is 0, so we have u is equal to half e1. Let us suppose this is equation number 4, and v is equal to again d by dt of del t over del v dot minus del t over del v, which is equal to d by dt minus half e2. And this may be simplified further as f1 minus half e2. This is equation number 5. Now using 4 and 5 in the equation 1, we obtain half of E1 f minus f1 minus half E2 into E is 0, and this equation gives E2 plus f E1 minus twice E f1 is equal to 0. So from here, if you simplify this equation, then you will get this equation, which is the statement of the theorem, and now theorem established. Thank you very much. Thank you.